Okay, so let's start this chapter, units and dimension. So our purpose of this chapter would be like in a crisp way. I would like to provide you all the important concepts of that chapter. So we have 30 chapters. I would make video on each of the chapters, as well as I would upload them in the playlist section. So like every chapter would have its own playlist, so that you can go through it for revision and getting your concepts reinforced. Okay. So this chapter, units and dimension, chapter number 1, class 11th. So we'll start with this one. So first thing that we have to understand is physical quantity. So physical quantity is simply any quantity that can be measured, right? If you can measure it, it would be physical quantity. If you can't measure it, it would be non-physical quantity. So physical quantity, if I say, means mass, length, time, temperature, force, velocity, acceleration. So all these quantities that can be measured and that we measure in physics are called physical quantities. On the other hand, that one which cannot be measured are called non-physical quantities. Examples are like emotion. Emotions we can't measure, right? Intelligence, sadness, happiness, these things we cannot measure, so they are called non-physical quantities, and we do not have to do anything with them. Obviously in physics only. In our life they have a lot of much more important role to play. Okay, so do not ignore that part. Well, so the physical quantities are that can be measured. Now physical quantities are of two types. Physical quantities are of two types, fundamental as well as derived. So if I talk about fundamental quantities, so we have 7 fundamental quantities plus 2 is there. Okay, fundamental basically means independent of each other. So they are independent, they are basically building blocks of measurement, base of measurement. They are the base where we do measurement, especially in physics. Okay, so all going good. Fundamental. Now derived would be anything apart from the fundamental, that would be called what? Derived quantity. So apart from the 7 plus 2, anything that would be there, that would be called derived quantities. Okay, so let's see this 7 fundamental quantities. Mass, we have length, time, temperature, current, amount of substance, and luminous intensity. So these are the 7 fundamental quantities on which the whole concept of physics has been built. Okay, a little bit, I think this side clear. Now every fundamental quantity has its unit in which we'll measure it. So mass can be measured in kilogram, length meter, time will measure in second, temperature we measure in what? Kelvin, current ampere, amount of substance we measure in mole, luminous intensity is measured in candela. So these are the units of 7 fundamental quantities. Okay, 7 fundamental quantities and their respective units as well. Apart from unit, there is one more thing that is very important here, that is dimension. So dimension basically says that any physical quantity depends on fundamental quantities. How does it depend on those fundamental quantities? So the idea is given by the dimension. Okay, so if anything depends on mass, we'll write its dimension as m, means it depends on mass. There is a component of mass in that physical quantity. Similarly, for length we write L. These things are written in box. For time, T. For temperature, simply K. For current, ampere. Mole, sometimes it is written as MOL, sometimes it is written as like dimensionless. Luminous intensity, candela, CD. So these are the fundamental quantities, 7 fundamental quantities as well as their dimensions. Okay, so you have to remember all of them. and based on them we will work on a lot of dimensions also. Okay. Okay, so let's work on some dimensional formulas of various physical quantities. So apart from those seven, you always have to remember. Now, apart from them, we are going to derive some of the more dimensional formulas, and these are also you have to remember because they are important ones. So at least 30 to 35 dimensional formulas you have to remember so that you can solve good amount of questions also. So dimensions, velocity. If I talk about velocity. So for dimension, we need to understand, we require two things basically. Either we have a unit or a formula. So if either of the two things are available, we can easily write down the dimensions of any physical quantity. Okay. What we require? We require unit as well as either unit or any formula is given. So for example, velocity. Velocity, we know the distance upon time. So distance is how much? L, and time upon t. So how much? LT minus 1, simple. So we can say velocity depends on a length parameter as well as on the time parameter, right? Velocity clear. Second, we can write down acceleration. So acceleration would be how much? So acceleration unit we know meter per second square. So meter is what? Length upon means divided by second square means t square. So LT minus 2. Easy, without any difficulty we can work on this one. Okay. Third one, if I talk about force, so force would be how much? Mass into acceleration. Mass capital M, acceleration we just written MLT, so MLT minus 2. This is force. Clear? Now I hope you can practice, you can understand, you are able to understand the concept that is being involved here. So things are quite simple at this point of time. If you talk about pressure, so pressure would be how much? Force upon area. Force how much? We just wrote MLT minus 2. Area is how much? L square. So ML minus 1 T minus 2. Few times you will revise these things, automatically it would be settled in your here, that is called subconscious brain. So you do not have to worry about remembering these things. Okay, just revise them through 2 to 3 times, automatically it would settle down. Okay, next one, fifth, work. So work is given as force into displacement. Force MLT minus 2, displacement L, so ML 2T minus 2. Okay, work. By the way, energy and torque, these three things, work, energy and torque, both have same dimension ML2T minus 2. Just mug it up. Work, energy, torque have same dimension. Work, energy, torque, ML2T minus 2. Okay. Next one, momentum. Linear momentum, formula is mass into velocity. So MLT minus 1. Seventh one, angular momentum, formula is mass velocity into distance, MVR. So mass M, velocity LT minus 1 and R. So ML2T minus 1. Okay. 8. Okay, what we can do? Modulus. Modulus of rigidity. So we have three modulus: Young's modulus, bulk modulus, and shear modulus. Let's see how to connect this. No need to mug up, simply you can connect. So there is a formula that is stress equals to modulus into strain. Stress equals to modulus into strain. Strain. Strain is basically given as change in dimension upon original dimension. These are the topics that we will discuss in rigidity solids chapter, but here just we are using little bit. So change in dimension upon original dimension. So basically it would be dimensionless only, no? Change in dimension has the same value of the dimension upon dimension, same unit, so they would cancel each other. So strain is what? Dimensionless quantity. So strain is dimensionless. M0, L0, T0. Clear? It means Young's modulus is nothing but what? Stress. So Young's modulus is nothing but stress, and stress is nothing but force per unit area, that is pressure. So Young's modulus is nothing but pressure, ml minus 1 T minus 2. So Young's modulus is nothing but pressure. Not only Young's modulus, all these modulus, Young's modulus, bulk modulus and shear modulus, these all are what? Pressure. So they would have same dimension. Okay. Okay. Then we have thermal coefficients. You might have heard of thermal coefficients of linear expansion alpha, surface expansion beta, and volume expansion gamma. These are thermal coefficients. Coefficients of thermal expansion. Coefficient of thermal expansion, linear, surface and volume. So all of them has K inverse, Kelvin minus 1. All of them per degree Celsius, per degree K, per Kelvin. So K inverse. Okay, now we are going to see very important, two important rules to solve the problems in dimensions. Involving dimension, any problem would be there. Will you solve them using these two rules? So these are very important rules. Okay, two things you have to keep it in mind to solve the problems. First one is homogeneity. Okay, principle of homogeneity of dimension, important from the board's point of view also. So principle of homogeneity of dimension, what does it say? Simple. We can add two quantities or we can subtract two quantities. So we are adding two quantities as well as subtracting two quantities in physics. So this is only possible, this is only doable or only meaningful if dimension of A equals to dimension of B. Similarly, subtraction also. So we can add or subtract two quantities or multiple quantities when both are what? Dimensionally same, and resultant after adding would be also of the same dimension only. So A and B we are adding and we are getting what? Y. Suppose we are getting we are adding A plus B and we are getting Y. So it means dimension of A must be equals to dimension of B must be equals to dimension of Y. Clear? Very simple principle of homogeneity of dimension. Addition, subtraction only possible when they have same dimension. Okay, no need to worry about. Important point, it is not applicable for multiplication, not applicable for division, only applicable for what? Addition and subtraction. Okay, this is rule number 1. Similarly, we have one more rule, rule number 2. This says that inputs and outputs of mathematical functions are dimensionless. These are dimensionless. Inputs and outputs both of a mathematical function are dimensionless. For example, if you write y equals to sine of what? K into x. Okay, y equals to sine of k into x, or let's say y is the distance. So y equals to a sine kx. We have written it. Now what is the input here? So input here is how much? Kx. So sine is a mathematical function, so input must be what? Dimensionless. M0, L0, T0. So kx must be dimensionless. So if you want kx to be dimensionless, so k must be 1 by x dimensionally. Got it? So this approach is very important to solve multiple type of problems. For example, e power at is there. Okay, so e power at. So e is an exponent, means mathematical function. So input is what? At, so at must be dimensionless. So A must be equals to how much? 1 by T dimensionally. Clear? So these two rules are very important to solve the problems from dimensional analysis. Okay. So let's see some problems based on the approach that we saw. P plus A by V square, V minus B equals to RT. Okay. Very popular equation that is called real gas equation. PV equals to nRT you might have heard of. That is a simplification of this equation itself. This equation is called van der Waals equation, real gas equation, or van der Waals equation. Okay, van der Waals equation or real gas equation. Now the question is, what are the dimensions of A and B? Okay, so let's see this. Till now, we just saw two important rules to solve dimensional problems. Those rules were addition, subtraction, they must be same dimension, and second rule was what? Mathematical functions must be dimensionless. So here addition, we are adding two things. So P must be equals to what? A by V square dimensionally. So dimension of A must be how much? PV square. Clear? Pressure we can directly write otherwise like this, P into V and V. Let's see this PV. So PV is nothing but work. Okay, pressure into volume is work. So ml2 T minus 2 and volume is how much? L3. So it would become ml power 5 T minus 2. That is dimension of A. Clear? Simple problem. For the B part, we are subtracting volume and B. So B must be the dimension of volume. So dimension of B how much? L cube. Okay. Similarly, next problem. Let me see the problem. Okay, so one more type of problem we have. They are saying that force, velocity, time, they are fundamental. We know that they are not fundamental quantities, but what we will do? We are not going to see them, right? So we'll just assume that force, velocity, and time are what? Fundamental. So from this force, velocity, time, we need the dimensional formula of density. It's a very particular type of question in dimensions. We need the formula of what? Dimension. In terms of what? Force, velocity, and time, because they are considered to be what? Fundamental. Okay. This is one type of problem, and same approach for one more type of problem would be there. Like suppose let's say that same problem, I can rephrase the same problem like this: density depends on force, velocity, and time, then find the formula of density. Okay, density here depends on force, velocity, and time, then we have to find the formula of density. Or other one, next one is written here: force, velocity, time are fundamental, then what is the dimensional formula of density? So both these two questions are basically similar only. Approach is similar, answer would also be similar. So what we have to do here? So we have to do that density depends on how much? Force power A, velocity power B, time power C. That is the formula. Now density we know, mass per unit volume. So mass M, volume L3, or I can write it simply like this: ml minus 3, that is density. This side force how much? mlt minus 2 power A. Velocity how much? lt minus 1 power B, time t power C. Now an equation is only correct if dimensionally correct from both sides, right? Left hand side dimension should be equals to right hand side dimension, then only it must be correct. So if you talk about the power of m here, so 1, power of m from here A, nowhere else. So A equals to how much? 1. L power how much? Minus 3. So L power how much here? A plus B. So A plus B is minus 3. A already how much? 1. So B equals to how much? Minus 4. So A clear, B clear. Time, if I talk about this side, left hand side time how much? 0. Right hand side minus 2A minus B plus C. We have the values. So minus 2A. So minus 2A1. B is minus 4 itself. So it would become plus 4 plus C. So it is C plus 2 equals to 0. So C equals to minus 2. Okay. So density. So density was how much? Force power A, F power A, 1. Velocity power B, so V power minus 4 and T power minus 2. So that is the dimensional formula of density in terms of force, velocity and time, where force, velocity and time are assumed to be what? Fundamental. Clear? Easy, right?